Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I'd like to talk to you about ACI Programmability Part 1, the ACI Object Model. Now, this is a part of our Network Programmability Basics video course, and we are in the Network Controllers module. We've already covered quite a bit in this module, including an introduction to using ACI programmability in God-SDN. In this lesson, we're going to dive deeper into the object model and how it builds the foundation for the REST API for ACI. In the following lesson, we're going to look at the ACI toolkit a little bit more, which is a mechanism for quickly getting started building Python scripts for network automation using ACI. If you'd like to follow along with me, I highly encourage it. Run on up to GitHub, github.com/CiscoDevNet, netprog_basics, and you can download all of the code for all of the examples across the entire video course. Every lab includes a README with prerequisites on how to set up your own workstation to follow along with all of the code examples. And every lab that requires infrastructure is backed by DevNet Sandbox, and the specifics about which sandbox to reserve or leverage are included in those READMEs. In this lesson, we're going to dive into the model-driven programmability for application-centric infrastructure and look at the management information model that provides the foundation for all of the objects structured inside of ACI. We'll look at how we can use the built-in tool of Visori to navigate that object model and look at children and parents, and then convert those object requests from Visori into API calls that we can make using Postman as a utility. So inside of application-centric infrastructure, it was designed from the ground up for programmability, and specifically model-driven programmability. The REST API provides the access to that object model, and it doesn't matter what interface into ACI you're using, be it the web GUI, one of the SDKs, or even a utility like the vSphere plugin. They are all built on top of that REST API. Now, it is a true REST API that targets the resources known as objects inside of ACI. Every object offers properties relative to the class, the type of object that it is, and you can access operational as well as configuration data. Now, using the REST API natively is much more powerful than some of the other programmability tools, such as ACI Toolkit, that are out there. However, it does have a bit of a steeper learning curve that we hope to accelerate your journey along in this lesson. Now, the object model is foundational to everything inside of ACI. It is a tree structure where every object has one parent, and every parent can have many children objects through it. We build relationships between the branches so that one branch can be related to an object in another one. And everything starts up at the root of the tree. Now, the construction of that tree, of connecting the children objects to their parent objects all the way up to the root, is how we create the management information model, or the MIM. The management information model gives you that description of everything in ACI as an object. And each object does have a class. We'll talk more about the classes in a minute, but we have classes for application profiles, we have classes for tenants, we have classes for interface types and EPGs. Now, the relationships between the parent and the children are one-to-many. A single parent can have lots of children, but a child will only ever have one direct parent. And as we connect those children up to their parents and their parents, all the way up to the uni, which stands for universe, that's what gives us the management information model. Inside of the model, every object will have two names, a relative name, or an RN, and a distinguished name, or a DN. Now, relative names are how we identify an object related to all of its siblings, the other elements directly underneath of a parent. The distinguished name is a unique identification across the entire information tree that goes through there and is assembled by connecting all of the relative names together up to the top level of uni. Now, we can use an example of family names to go through here. So inside of a family, and for example here, the Smith family, we have Tom and Jill. They are children of Mr. Smith. And inside the family, they can be referred to simply as Tom or as Jill. But if we need to talk about those specific children inside of a school or a larger family, we use the distinguished names of Tom Smith and Jill Smith to uniquely identify those children inside of the family. We can see that same thing across the object names inside of ACI. Here in this table, we can see that we've got several of the objects available inside of ACI, starting with the system, which is given a name of uni. Now, as we build from there across tenants and VRFs, we see examples of how we construct RNs and their relative DNs. For example, a tenant's RN is the letters TN dash followed by the unique identifier for that tenant, in this case, heroes. If we want the distinguished name for that tenant, we would then connect the TN heroes to its parent, which is uni. We can see these examples as we go down to things like an EPG. An EPG is given a relative name, an RN, with EPG dash and then the identifier for the EPG, in this case, database. Now, an EPG's parent is an application profile. The application profile's parent is the tenant, and the tenant, once again, goes back to uni. So when we provide a distinguished name for an individual EPG, we start with uni, then tenant heroes, then application profile, save the planet, and then finally our EPG of database. This table also shows the classes that each of these objects are a member of. And these class names are useful when we start to construct the API calls and we want to make class queries. Now, this is a small cheat sheet of all of the different objects and names and RN formats and DN formats inside of ACI. For the full ACI model reference, be sure to look up on DevNet, where you can find all of the latest information around ACI programmability. Now, with this bit covered, let's go ahead and look at how we can explore the object model using Visori. Now, Visori is a tool that is hosted on the APIC and is there by default. You can access it by navigating to your ACI controller /visori.html and logging in. This gives us the ability to navigate the entire object model and even expose the ACI REST API calls for particular objects across the model and query. If we look at the interface for Visori, it starts out at the top with where we can identify the class or the distinguished name that we're interested in searching for. We can provide filters so that we can hone in and return just the results that match a filter that we're after. For example, if we want to do a class query for all tenants, but we're only interested in a specific tenant, we can use the property filters for that. Below, we see the results of the query that are active. This results list may be scrollable depending on how many results were returned. Inside of every result object, we have indications so that we can dive in and we can navigate the tree by looking at the parent or the children using the green greater than and less than symbols. If we're interested in statistics, faults, or health information about a particular object, we can see those using these through the tree as well. We'll also see the full distinguished name and a link so that we can actually bring up that single object inside of Visori within the interface. And then lastly, we have the option to view the REST API details. We can see the URI of the last query that was run so that we can leverage that as we try to translate from Visori into other tools such as Postman or our scripts. If we look at here, we can see how we can use Visori to search by a specific class. For example, if you're looking for everything of a specific type, all application profiles, all EPGs, or in this example, all tenants, we can use Visori to search by that class. The tenant class name is fvTenant, and in this case, we're filtering down to return all tenants other than the common tenant. And then in green, we can see the actual URI that was leveraged to make this call. We'll see how we can use those inside of Postman in the next section. Once we've made this query, we can go ahead and review all of the results in a scrollable web browser. And across each one of these objects, we can see how we can navigate the tree for their parents and their children. Now, if we want to instead of searching for everything in a particular class, we can also use Visori to search by a specific distinguished name. And so if we want to look for a specific application profile, we can simply assemble its distinguished name and put that into the Visori search box. Now remember, this is the distinguished name, not the RN. So we do need to start with uni, go through the tenant, and then finally into the application profile. Once we have that, we can actually look at how we construct the URI for this query and see how those are assembled and built. Now that we've looked at Visori, let's actually do a demonstration and see how these tools are used to navigate Visori, look at children, and some of these other areas. All right, here we've seen I've opened up the Visori interface to an ACI controller, our DevNet Sandbox, or APIC. Now, as we talked about, we've got the ability up at the top to do queries, we can filter down, and then we'll see the results objects down here. Now, one of the things that I like the most about Visori is the ability to navigate up and down the object tree. So we're starting here at the top underneath the uni, but I can go ahead and I can look at the direct children directly underneath the uni. And I can see that there are 48 direct children that come through. And if I scroll through, I'll see several different objects that are in there. Now what we want to look at here is, let's say we want to do a class query for a particular type of object. I'm sticking with consistency, we'll talk about tenants. And so I can do a class query of FV tenant, which is the name of the actual tenant class that we're looking for, and I can search for those. It'll say, hey, you didn't specify a property name. Are you sure you want to find all instances? Yep, indeed I do. I make that search, I'll see that I'm getting 8 tenants back. It starts out with common, and then if I scroll down through, we'll see that we've got a tenant called test, and then we see some other tenants that are in there. Now, if I'm looking for a very particular tenant, I can filter those down by providing details that are in here. I can say tenant, and then the name of this tenant that I'm looking for is, we'll go with our heroes tenant. So I'll say I'm looking for name, heroes. Let's see if I can type it correctly. So if I run this query, this will go through and it should return back just the matching tenant, and indeed it does. I get my tenant heroes. Now one of the things that's nice, we'll look at how we can take the output from Visori and use that inside of Postman. And one of the ways we want to do that is see the URI of that last query. So by clicking on this link, I can see that this is API, node, class, fvtenant.xml, and this shows me how I can actually drill in and see the very specific URL of what we're looking for. Now if I want to see the children of a particular tenant object, once again we click the arrow here, and this will take us in, and we can look at the application profiles that are within this tenant. We can see the bridge domains that exist within this tenant, and all of the other children that are available inside of the policy model for here. Now navigating Visori, or navigating the ACI object model with Visori is great. Now we're going to move ahead and see how we can actually use the information from Visori with API tools. We'll put Visori behind us for just a moment, and we're going to move into how we can use that REST API with Postman using what we know of it from Visori. Now, as a reminder, Postman is a simple but powerful REST API client. It lets us quickly test APIs using a GUI, save them into collections, and manage multiple environments so that we can use those same API calls across different APIC controllers. Before we can use Postman, let's have a quick discussion about how we construct the REST API calls for ACI. So the way the format goes through here is we will start out like most REST APIs with the address of the APIC controller. We'll then go through the main entry point for the ACI REST API, which is just API. Now then we get into the query types. So when we saw in Visori that we can make both class as well as distinguished name-based queries. Inside of the API, those correspond to either a class query type or an MO, which stands for managed object. Following the query type is our identifier. This will be the class name or the distinguished name that we are looking to make our API call against. Following the identifier is the format, and that'll either be .xml or .json to determine which format it is that we're interested in working with. Now this is different than the more typical use case for how you distinguish formats with a REST API by using HTTP headers. The ACI API uses this .format mechanism in the URI. And then finally our URI will be has an area for query parameters. These are optional parameters that can control the results that are returned. For example, we can use query target to either return back just the object that we specified, that object's children, or the subtree, which would be both the object and its children. And then for class queries, the query target filter gives us the ability to return only a subset of all of the elements inside of a particular class. Now, as all of our Postman exercises go through, we need to set up our environment for ACI, the ACI environment inside of Postman. So here we can see we're including the APIC controller address, the username, password, and port, and then we can use those inside of login requests, which are the first step that we need to take when making API requests using Postman. ACI leverages a ticket, a token mechanism, in order to provide that authentication back for all of the API calls. The only time you'll ever use a username and password inside an API call to ACI is when making this AAA login.json request. We post off to that, and that will give us back our token in the response body. Now that token is included inside of a session cookie that Postman, as well as all other web clients, will automatically transport back and forth between your client and the ACI controller. Once we've logged in, now we can take and translate our request from Visori into Postman. So now we're going to recreate our request from Visori inside of Postman, where we query for all of the tenants using a class query. So we can take that URI directly out of Visori and paste that into Postman, and because we're retrieving information, this will be a GET request. When we send this information off, we can then review the response details that come back, in this case in XML. Now, a couple of things we can do to explore these API calls is we can see how we can convert from returning the data in XML to JSON by changing from .xml to .json inside of the URI, and that would simply switch over the exact same data, but now return it back in JSON format. Now, with our query done for a whole class, we can also do object queries to target, in this example, an application profile. So the application profile, our API call, will once again be a GET, but now instead of a class query, it's an MO, a managed object query, and we provide the full distinguished name of uni, TN heroes, AP savetheplanet.json. Once we've made that, we can then review the response details that come back. Now, this is a REST API, which means we have the ability to not just retrieve information, but edit details. So by using and building on this GET request, let's convert this to a POST request where we provide updates back into the object model. In this case, we'll provide a new description configured with the REST API. You'll notice inside of the body, we don't have to provide the full details for this object. We do need to provide the distinguished name and then whichever attributes we want to update. After we send this request off to ACI, we can review the status code. In this case, we'll see we get back a 200 OK, indicating that this was a successful update. You can verify that by returning back to a GET query to see that the results have actually changed and are including a new description now. Now, we looked at a couple of the REST API methods, but there are full methods for both create, read, update, and delete object options inside of the REST API. Now, the GET HTTP method that we've seen will let you retrieve details. Now, if you want to create or update an object, POST will give us the ability to do both of those. And then finally, to delete, we have the delete method inside of HTTP. All right, in summary, we took a quick look at the ACI API as well as the object model. We saw how that object model is fundamental to everything inside of ACI programmability and how the management information model actually provides that basis for everything that we do. We explored the object model using Visori, the built-in utility for data model navigation inside of ACI. And then finally, we saw how we can take those API calls from Visori and make those requests using Postman. Now, as a call to action, make sure you complete the full Network Programmability Basics course. We'll be back in the next lesson where we actually move from the API and into the ACI toolkit to make it very easy to start navigating and building Python scripts for using ACI programmability. If you didn't follow along and run the exercises with Visori and Postman along with me in the video, be sure to do that yourself before you move too far ahead. Also, make sure you join DevNet for more learning labs and development sandboxes across a whole range of development topics. If you have questions on this or any other topics, feel free to find me directly. You can reach me via email at hapresto@cisco.com or through Cisco Spark. I'm active on Twitter at hfpreston as well as on GitHub at hpreston. And Cisco DevNet is available on all the social medias from Twitter, Facebook, GitHub, Instagram. We're all over the place up on the web. Be sure to follow for the latest information. As always, thank you for joining me on this lesson, and I look forward to seeing you on the next one. Thanks.